Solar and lunar eclipses are among the most astonishing sights in nature. Ancient people were probably frightened to see an eclipse and explain it with different mythologies, while nowadays thousands of people travel to remote spots searching for the opportunity to witness those events. In this video, we describe the types of eclipses and why they occur. The Moon and Earth cast shadows in sunlight. Occasionally, the Moon passes through the Earth's shadow and a lunar eclipse occurs. Anyone on the night side at the time of the eclipse can observe the obscured disk of the Moon. Under different conditions, the Moon's shadow falls on Earth and a solar eclipse is produced. A person located inside the pathways of the shadow will see the Moon gliding in front of the Sun, cover its disk, and experience the darkness in plain daytime. Let's take a closer look at lunar eclipses. A necessary condition for a lunar eclipse to occur is that the Sun, Earth, and Moon fall into a straight line with the Moon opposite the Sun in relation to Earth. We might wonder why, if the Moon orbits Earth once a month, we don't see lunar eclipses every month when the Moon opposes the Sun. To answer that, it is necessary to know a few details about the geometry of the orbits of Earth and Moon. The plane defined by Earth's orbit about the Sun is known as the ecliptic plane. Note that the shadow of Earth is centered on that plane. The orbit of Moon about Earth is not in the ecliptic plane. Instead, it's inclined by about 5.2 degrees. The line along which the plane of the Moon's orbit intersects the ecliptic plane is called the line of nodes. Eclipses cannot occur when the inclination of its orbit places the Moon below or above the shadow of Earth. Eclipses can only occur when two conditions are simultaneously met. First, the Moon must cross the plane of the ecliptic, which occurs at the line of nodes. Second, the line of nodes must point towards the Sun, or in other words, the line of nodes must lie along the shadow of Earth. Note that there are only two periods of the year during which the line of nodes points close enough towards the Sun to produce eclipses. Those periods are called eclipse seasons and have a duration of 38 days each. Outside the eclipse seasons, the line of nodes is not aligned with the Earth's shadow and a lunar eclipse cannot be produced. A closer inspection of the geometry of the shadow cast by Earth reveals that there is a region where sunlight is completely blocked, known as the umbra, and a region where sunlight is only partially blocked, known as the penumbra. A lunar eclipse starts when the Moon enters the penumbra. If the Moon only passes through the penumbra, we have a penumbral lunar eclipse. It can be difficult to notice a difference in the appearance of the Moon during an eclipse of this type. If only parts of the Moon passes through the umbra, we have a partial lunar eclipse. You will see a distinctive shadow gradually covering part of the Moon in a couple of hours. The curvature of Earth's shadow on the Moon was cited as evidence of a spherical Earth by Aristotle 300 years BC. When the Moon passes entirely through the umbra, you'll see a total lunar eclipse. Because Earth's shadow is much larger than the Moon, the entire Moon can be covered during the eclipse, and anyone located on the side of Earth facing the Moon can see it. During totality, the Moon becomes dark with a peculiar red tint. That color occurs because red light from the Sun is slightly bent as it travels through Earth's atmosphere and illuminates the Moon. Light of other colors, such as blue and green, is dispersed in all directions away from the Moon. When the Moon casts its shadow on Earth, a solar eclipse is produced. From Earth, we see the Moon covering part of the totality of the Sun. The Sun is about 400 times the diameter of the Moon, and the distance between the Sun and Earth is about 400 times more than the distance between the Moon and Earth. As a result, the much smaller moon has almost the same apparent size as the sun in the sky, and this happy coincidence makes solar eclipses possible. Similarly to lunar eclipses, not every time the moon passes between the sun and Earth, a solar eclipse is produced. Due to the inclination of the moon's orbit, its shadow sometimes passes above or below Earth. Only when the line of nose points towards the sun during the eclipse seasons, the moon aligns with the sun and Earth, casts its shadow on Earth, and a solar eclipse is produced. As it passes Earth, the moon's penumbra has a diameter of almost 7,000 kilometers, a bit more than half the diameter of our planet, and large enough to cover a substantial fraction of its surface. Thus, from any particular location on Earth, you are more likely to observe a partial solar eclipse in which the moon blocks only part of the sun's disk. A total eclipse can be observed from the region in which the umbra touches Earth. The moon is observed gradually passing in front of the disk of the sun until it's completely covered. The region where a total solar eclipse can be observed is limited to the pathway of the umbra. Because under the best conditions, the moon's umbra is only 270 km wide on Earth, the path of totality covers only a small fraction of the Earth's surface. As the totality approaches and the sky darkens, temperatures fall, fauna prepares for the nighttime rituals, and the excitement of enthusiast observers increases. During the few minutes of totality, the moon completely blocks the sun and the stars and planets suddenly become visible at daytime. Only under these very special conditions, the sun's outer atmosphere is visible to the naked eye as a haze extending millions of kilometers into space, and magnetic eruptions are revealed close to the sun's limb with a deep magenta color. Definitively, witnessing a total solar eclipse deserves a place on your lifetime to-do list of extraordinary experiences.